I'm Shravani, Assistant Professor from the Department of CSC. Today we are dealing with course Design and Analysis of Algorithms. My course objectives are here, as I said, the course name itself, it is having three words: design, analysis and algorithms. So here design means here we have to design new algorithms. So why we need algorithms? Because here we have to find the solutions for any problem. The basic need of a CSE student or CSE people is to find the solutions for problems. So those solutions we are depicting with the help of algorithms. And once an algorithm is designed, it is very easy to convert into any programming language. So that's the reason any CSE student has to design the algorithms to solve any problem. So for that reason, we are learning this course. And why the analysis part is required? Because here a student, let us consider two students have designed the solutions for a problem, such that here the first student have solved the same problem with 50 lines of code, whereas the second student has solved the same problem with 10 lines of code, such that which you will select. Generally, most of the students says that the first one is somewhat quite lengthy, so I'll select second one. But the thing is, another constraint is added to this problem, such that here the first student who has developed 50 steps, okay, 50 steps solution, that 50 step solution can be solved in 10 microseconds. Whereas the second one, which is 10 step solution, which can be solved in 15 microseconds. Now, I said the execution time or the solving time. So now first one is 10 microseconds and the other one is 15 microseconds. Now what you will select? The first one only. Although it is quite lengthy, we will select the first one. Why? Because now we have analyzed the algorithm such that my first one takes less time, although it is lengthy, and my second one takes more time. So always we have to do we have to solve our solution such that it should be solved in a less time and also less memory space. So here we are here in this manner we are going to analyze our algorithm. So that analysis part is also complete, that is also be there in my course. So now coming to the course objectives. Objective means first of all what you are going to learn as part of this course. So here this particular course is explain you how to design the algorithms for your problems. So such that one can design the algorithms for any type of problem, and also we are going to analyze the algorithm by taking some performance measures. The performance measures are space and time complexity. Those we will discuss in detail in my first unit. Next, and also whenever a new problem is given to a student, that new problem can also be solved. That new problem can also be solved with the programming paradigms which we have learned as part of this course. So a student can be able to devise algorithms for new problems also once this course is completed. Now course outcomes. Outcomes means what a student is able to know after completion of this course. So after completion of this course, a student can analyze the performance of algorithm in terms of time and as well as a space complexity, and also he can find the solution for larger problems. So how to find the solution for larger problems? He is going to divide the given problem into smaller sub-problems such that each sub-problem is getting to be solved, and after that we will integrate all the smaller sub-problem solutions to get the overall solution for the given problem. So this is what we'll have in the second unit called divide and conquer. So this is also one of the outcome. And also whenever a new problem is given to you, so which programming paradigm I have to use in order to solve the given problem. So even that particular programming methodology is also can be selected once you have learned this particular course. So easily you can select such that for solving this problem the divide and conquer is used, or else dynamic programming is used, or else backtracking can be used. So if I use this, I could get the solution in a less time. So likewise I can have the vision once you have completed this course, and also you can design the solution space for a given problem using branch and bound. The branch and bound concept is going to be covered in the last unit. Now basically here as I said, my course is having 3 words: design, analysis and algorithm. So now what is an algorithm? An algorithm is basically a finite set of instructions to perform a particular task. Finite. What is finite? Finite means countable. Okay, countable set of instructions to perform a specific task. Now coming to the examples. Okay, searching a book. So for example, I went to library. I am searching for a book. Okay, whose name is Web Technologists and whose author is Chris Bates and whose edition is 3rd edition. So now my library consisting of around 1 lakh books. So immediately when I am entering into it, immediately I could not get the rack, okay, where it is exactly available. So for that, immediately you will go to OPAC of your library, and in your OPAC software, you'll type the author name as well as the textbook title as well as the edition. So immediately you'll get where it is exactly available, which is a rack number and also the rack place and also the book corresponding place also you'll get it, or else whether the book is available or not also you could learn, you can know easily by going through that software. So here how you are going to know that? Here initially one software engineer has developed an algorithm for that OPAC software to check the availability of the book. So this can be done by implementing some algorithm, right? So here these are all examples of your algorithms. Now algorithm techniques. Basically we have different programming paradigms or different types of methodologies to solve a problem. So the first one is divide and conquer, next dynamic programming, greedy method, backtracking, branch and bound. These are the different programming methodologies. So these out of which the first 5 will be covered as part of your course, and the remaining 2 will be covered as subtopics of your course, and whereas the first 5 are the main topics. Now unit 1, coming to your unit 1, introduction to algorithms. So introduction. So what is an algorithm? The definition as well as the specifications or rules of your algorithms or pseudocodes, and also the recursive algorithms, how to write the recursive algorithms, and the performance measures, space complexity and time complexity, and also asymptotic notations, which are the high level mathematical notations to represent an algorithm. For suppose here big O of n as a asymptotic notation, where within n time my particular algorithm gets completed. So those asymptotic notations and amortized analysis, Master's theorems, and so some sorting techniques are also covered as part of your unit 1. Next, second unit is coming under divide and conquer. So divide and conquer, as I said earlier, here once a larger problem is given to you, that larger problem is getting divided into smaller sub-problems such that each sub-problem gets solved, and finally after that all the sub-problem solutions are integrated to get the overall solution. So that divide and conquer is one of the strategy, and that we are going to cover as part of our unit 2. And there are certain number of applications, binary search, defective chessboard. These are also we are covering under unit 2. Next, greedy method. Here an objective function is given, and based on that objective function we are going to retrieve the solutions. Those solutions are feasible solutions, and from that feasible solutions we are going to select one of the optimal solution. And coming to why the name is given greedy. Why means here we are going to take even the fractional parts of a particular item or of a particular thing or of a particular object. So here we are not taking a full item. We might take even the fractional part of the object also as part of your greedy method. That's why the name is given as greedy. And there are several applications. Those applications also we are covering. And as I said earlier, randomized algorithms, even the randomized algorithms are also come under unit 3. Now dynamic programming. So this dynamic under dynamic programming we are generating some dynamic tables. Okay, from that table we are generating our optimal solution by using the principle called principle of optimality. So these are the applications covered in your dynamic programming. Chain matrix multiplication, 0 by 1 knapsack, and whereas in your greedy method knapsack problem, and now it is changed with 0 by 1 knapsack. Why? Because in your greedy, we will take even the fractional part of your item, whereas in under 0 by 1, either we will take the full item or else we will not select any of the item. That's why it is 0 by 1. And also we will color, we are having one more subtopic which is multi-threaded algorithms. And the next unit is come under backtracking. So backtracking means here we are going to generate a solution space tree such that whenever we are not finding any solution, then immediately we are tracing back and we are reaching our path to solution. So likewise we are going to solve our problems with the help of backtracking approach. For example, if you are going to chess. Okay, if you are playing a chess game, so at that time, for suppose the opponent, okay, if an opponent is given one action, so with that action, you are immediately calculating the next action to be taken, right? So basing on that next action, you are basing on the next action which you are taking. So basing on that, we are analyzing it and we are keeping our next step. How we are keeping our next step? Because if I am taking in this path, then I might lose the game. If I am taking in this path, I might win the game. So here by taking the decisions, you are playing your game. So here somehow you are utilizing your backtracking concept. Here you are not applying fully, but you are applying somehow you are applying the backtracking concept. Now, why we are learning as of third years, why we are learning this design and analysis of algorithms as part of your curriculum? Because it is very, very important for your placements as well as to achieve GATE exam. So here the product based companies, Microsoft, Amazon, Tech Systems, Value Labs, likewise we have number of product based companies and also service based companies, Infosys, TCS, Capgemini, right? So all these companies at present they are hiring with the help of an online exam, and here in your online exam you are going to solve some set of problems such that those problems they want to expect you to solve with the help of either a dynamic programming or a greedy approach, right? So here or a backtracking approach. So here these approaches you are going to learn in this course. That's why this is very, very important for your placements as well as for your GATE exam. Even in your GATE exam also you will have more number of questions from this subject. And coming to the textbooks. Okay, here as I have shown you the images, right? So the first one, which is Chhatra Shahani, this book covers 80% of your syllabus, whereas the second book, which is Corman, it is going to cover 20% of your syllabus. If you want to learn more than that, then you can go with your reference books. And my suggestion is to have your Chhatra Shahani book, which is enough for your syllabus. Thank you. Bye bye. Have a nice day. Bye bye.